In this video, we're going to talk about the regression line and what it tells us about the data and some different things we can evaluate and how we can make predictions with this line. So the idea behind this is we see our data and we can see a roughly linear trend. And with this one, it could be a little difficult. There's a decent amount of scatter. This only has moderate strength, so it's not as clear as other scenarios, but it's kind of that reason that I like this one too, because everyone might draw kind of a different line here. So like some people might go maybe more like this. Maybe we go more like this. Basically, we want to imagine a line that is staying as close as possible to each of the data values simultaneously as possible. So it's trying to minimize those distances away altogether at the same time. And it's exactly that kind of calculation that finds this equation of the line. There are formulas for finding that equation of the line, but again, we're going to rely on technology for getting us that equation of the line, and then it's more about interpreting that equation and using that equation to make predictions. So for this scenario, our line is going to look something like this. Not exact, and we'll go to technology to get us there, but we have something like this. So this line right here is doing its best to minimize these distances away. So distance, I'm meaning like a vertical distance between the dot and the line. So it's trying to make those as small as possible, as much as possible. But you're always going to have scenarios where there's something that's further away, and that's fine. It's how it's calculated is making those as small as possible. These distances away from the line are called residuals. So if we focus on this point right here, if I imagine this vertical line coming on down, that would be called a residual. And it's because we have two pieces here that we're comparing. This dot right here, that was an observation. That was an actual flight that took place. They had the distance and the airfare for that particular flight. Then what we have is this point down on the line. That right there is a prediction. So that equation of the line is just mapping predictions, and what that line would be doing is, given that same exact distance, it would be predicting what the airfare should be. And it's predicting the airfare based on all of the other information and how the data is trending. What we're seeing here is the observation. What was observed was quite a bit different, and that's something we'll talk about in the next video. But we have these kind of two scenarios. For the same x value, we have these different y values. And the difference is one is an observation and one is a prediction. And we use slightly different notation for these two pieces. So let's put some notation. I'll put it right at the top here. So observed values. So those observations are coming from our data. So it'll usually be from a data table that is provided. And for those values, the notation we use is just y. That's what we've been using so far, nothing changing there. New piece are the predictions. So the predicted values are coming from the line. So that line is giving us all sorts of predictions based on the trend of the data. And for these, we use y as well, but we use y hat to show that it is a predicted outcome. So y hat comes from our line, y comes from our data. Okay, we'll come back to this and talk some more and get some more information there. But let's talk about this line of best fit. So line of best fit, regression line, or least squares regression line. All of those are the same. So just make note that there is different vocabulary, but they all mean the same exact thing. So it's going to be an equation of a line that we're getting at here. Visualizing that line, it's like using a ruler or straight edge to draw a line through the data and trying to make it follow the data as much as possible. Draw a vertical distance between each point in the line, and those are the residuals. So I only did it for one point there, but we could do it for all of these. So again, just a vertical line going down there. See, this point here is really close. That's a teeny tiny residual. And just little ones. So the further away means the larger the residual is, and then the closer, when we're really close, it's almost like we observed what was being predicted, essentially. So these residuals, we have an actual calculation to go with it, and what we do is we take the observed value minus the predicted value. And something to make clear here, so because we have x coordinates and y coordinates here, when we're looking at a residual, x stays the same. We're at the same x value for both of them. It's the y values that are changing. The outputs is where we're looking for the difference. So for the observed value, that comes from our data. So make sure you look to the data to grab that value for y. And then the predicted value, y hat, is coming from the equation of the line. So with that, we might have like a little calculation to do. I'm just kind of giving an overview of these pieces, and then what we're going to do is go back to that airfare example and talk through each of these. I just wanted to give a quick overview of these ideas here. So when we go to calculate residuals, we're going to get a difference. So we take observed minus predicted. And what we're seeing is if we are above the line, so for these values above the line here, if we take observed value minus predicted value, well, here we have a really large y value, and here we have a much smaller y value. So if we carry out that subtraction, we're going to get a positive residual. So all of these data values above the line are going to have a residual that is positive. So they're going to have a residual larger than 0 here. Now, let's imagine we're setting up to purchase this ticket here. And we have a prediction that we're going to pay close to $200 for this airfare. What happened here is when we went to go buy the ticket, it actually cost $400. So what we're seeing here is what we're seeing as an observation is so much larger than the prediction. And with that, what's happening in terms of the prediction underestimated what was happening. So what's happening above here is a bunch of underestimates coming from that equation of the line. So we'll talk about that some more, but above here, getting positive residuals means that we underestimated what's happening. Now, if we're below the equation of the line, say we're down here, so we take our observed value, so our y value there, and subtract the y value coming from our line. So we're taking something small and subtracting something larger, and that means we're getting a residual that's negative. So with a negative residual, with this case, it would be, okay, I'm going to buy a ticket. It is estimated it's going to cost $150. Then when I go to buy my ticket, it's actually $100. That's an awesome scenario. I like that. So what happened here is our prediction overestimated. And then if we land exactly on the line, which can absolutely happen, that means our prediction was perfect. So what's going to happen here is our residual is going to equal 0 because you're subtracting two y values that are the same. And then it means that we were exactly correct. So that prediction was exact. So part of the process here is we're going to calculate residuals. We're going to get a value out, and then we're going to want to interpret it as an underestimate, exact estimate, or an overestimate. So we'll talk about those pieces, but visually, I hope this helps to kind of see where residuals are positive, 0, and negative. Okay, one more piece of explanation, and then we'll go to the example here. But our least squares regression line, this is our equation right here. So we have our y hat that we talked about up above. Those are our predicted y values. And those predictions are coming in based on some value for x. So those are our two variables. Then what we have are we want to fill in the blank for two numbers. We want this number for b1 and we want this number for b0. Now, maybe you're seeing it already, but going back to our algebra skills a little bit, y equals mx plus b is our equation of a line. And that is exactly what we're using here. Our notation is changing just because of working with data and working in statistics, but we have our variables, output, input, and we should have some number for m and some number for b. And just as a reminder, m represents slope, and b represents the y-intercept. Or you can think of that as where x is 0. So with that, we're really working with just an equation of a line. Notation, we use b1, b0, but really it's the same as slope, intercept. So y hat is the predicted y value for a given value of x. So there's our description in terms of prediction. b1 is the slope of the regression line. So that matches up. It's if it helps, it's always what's multiplying x. So always look for x, and then whatever's multiplying with it is our slope. It is the expected increase or decrease on average of the y variable for a 1 unit increase in the variable x. So increase or decrease comes from whether the slope is positive or negative. And there are a few different ways that we can kind of make a sentence structure to help out. One that we can use is like y increases or decreases by, and then our slope. So I'm going to use b1 there. And then we could describe it as a rate, like y units per x units. We can try that out. Let's try that out with the example that we look at on the next page, but we could also fit this, it is expected increase, decrease on average y per 1 increase for x. So we can take a look at it two different ways and I'll explain the same thing. Then b0 is the y-intercept, and this is our y value when x is 0. So with that, making a sentence, it's just that if x is 0, y is whatever that number for b0 is. Okay, so I'll come back to this page as I go through the next example, but let's stop this video here, and then we'll practice these ideas.